Hi everyone, welcome back to the channel. Today, we're diving into the invisible but powerful force that drives everything from boiling water to global weather patterns. Convection is one of the three primary methods of heat transfer, along with conduction and radiation. But it operates specifically in fluids, both liquids and gases. It occurs when heat causes the movement of molecules within a fluid, leading to the transfer of thermal energy from one part of the fluid to another. This movement results in the formation of convection currents, which play a significant role in many natural and engineered systems. Let us investigate how convection works. Convection relies on the principle that when a fluid is heated, it expands, becomes less dense, and rises, while cooler, denser fluid sinks. This cyclical process creates a flow known as a convection current. The heat transfer begins with a heat source. This can be anything from the sun warming the surface of the earth to a stove heating water in a pot. As the heat energy is absorbed by the fluid molecules, they gain kinetic energy and begin to move faster. This increase in energy causes the molecules to spread out, making the heated part of the fluid less dense. Since the heated fluid is now less dense, it rises upward. As it moves away from the heat source, it loses energy and cools down, becoming denser again. The cooler, denser fluid then sinks to take its place near the heat source, where it will get heated once more. This continual cycle of rising and sinking fluid creates a loop known as a convection current. The heat is distributed throughout the fluid as the warmer portions rise and the cooler portions sink, setting up a steady flow of energy. A common example of convection in liquids is when water is heated in a pot. The water at the bottom of the pot, closest to the heat source, warms up, expands, and rises to the surface. As it reaches the cooler surface, it loses heat to the surrounding air, becomes denser, and sinks back to the bottom to be heated again. This cyclical process ensures that the entire pot of water eventually reaches a uniform temperature. Convection also happens in gases, such as in the atmosphere. The sun heats the Earth's surface, causing the air close to the ground to warm up, expand, and rise. As the warm air rises, it cools and descends again, creating convection currents. These currents are responsible for weather patterns, including wind and cloud formation. For example, the updrafts of warm air and downdrafts of cooler air can lead to storm development. Convection can occur naturally, as we discussed earlier, but it can also be forced using external mechanisms. Natural convection happens due to temperature differences within the fluid. It is responsible for natural phenomena like ocean currents, wind patterns, and even the circulation of blood in the human body. Forced convection involves an external force, like a pump or a fan, moving the fluid and accelerating the heat transfer. For instance, in heating systems, a fan may blow warm air around a room to distribute heat more evenly. Or a radiator may use water circulation to heat different areas of a building. Convection currents in the atmosphere are responsible for the formation of weather patterns. Warm air near the Earth's surface rises due to its lower density, while cooler air sinks, creating a circulation pattern. This process drives the development of clouds, thunderstorms, and other weather phenomena. During the day, the land heats up faster than the sea. The warm air over the land rises, and cooler air from the sea moves in to replace it, creating a breeze from the sea to the land. At night, the process reverses, forming a land breeze. Global conveyor belt is a large-scale ocean circulation driven by differences in water temperature and salinity. Warm, salty water from the equator moves toward the poles, where it cools, becomes denser, and sinks. This deep cold water then flows back toward the equator, creating a continuous loop. This process plays a critical role in regulating the Earth's climate. Convection currents within the Earth's mantle are a driving force behind plate tectonics. The mantle, although solid, behaves like a viscous fluid over geological time scales. Hot, less dense material from the mantle rises toward the Earth's crust, while cooler, denser material sinks back toward the core. This movement causes the tectonic plates on the Earth's surface to move, leading to phenomena like earthquakes, volcanic activity, and the creation of mountain ranges. Convection ovens are designed to enhance heat transfer by circulating hot air around the food, cooking it more evenly and efficiently than conventional ovens. Thanks for watching my video on convection. I hope you found it informative and useful. If you enjoyed learning about heat transfer and want to dive into more science topics, don't forget to subscribe to my channel. There is plenty more to explore, so stay tuned and I'll see you very soon.